given the expected return, the risk, and all other stuff, and we're asked to find the optimal risky asset and this mean variance portfolio. So it's very standard question, so just assign a weight for A and B. Suppose let's invest in our portfolio X in A and 1 minus X in B. Then the return, the portfolio return, is just the weighted average of the returns of individual ones, and the weights are just the X and 1 minus X. So 0.1 and 0.2 are these two numbers. And sigma p squared, the variance of this portfolio is just square them, so use this 0.1 squared. So these two are not the same 0.1s. Times x squared. So remember there is a square on this weight as well. Plus 0.4, which is this thing squared. Again, remember to square all of them. And also remember there's a 2 times covariance. So the covariance term is correlation times sigma A, sigma B, and x and 1 minus x. So first thing, remember the weights needs to be multiplied as well. And here this is 0, that's why the whole thing is 0. But if you have the numbers, you need to multiply it by it. Then, and also there's no square here, so it's just to the power 1. Let's erase that. And remember the 2 in front. So now we can do the optimal and mean variance one. Optimal one is just maximizing the Sharpe ratio, so RP minus RF. So usually we write the expected value of RP, let's add it, divided by sigma p. So here is sigma p, not sigma p squared, so there's no square. So I'll write square root of sigma p squared to make sure that is the case. And then you can first order condition it, but of course on the exam you don't have time, so you can just use the formula. Remember to copy that on the cheat sheet, and this is equal to, let me see, 0.787. And the mean variance one is the same idea, it's just literally just minimizing the variance, so sigma p squared. And then you can first order condition it, or you can again use another formula, not the same formula obviously. It's equal to 0.941. Okay, so after you have these two numbers, remember to substitute these two numbers back into this and this. So to get the, if you substitute this number back here, you get the expected return of this optimal portfolio, and you get the variance, or you need to square root it to get the risk of that. So the return is just the expected value of RP, and the risk is just sigma p. So substituting these two numbers, you'll get the return and risk of these two portfolios, and then you can plot those 2 points on. So this is the optimal one, this is the mean variance one. And then in the smallest possible diagram, that efficient frontier will look like this, and then the risk-free and this optimal should be tangent to each other.